This is frustrating. Hi, my name is Jason Wampler. All you hopeful Rocketeers out there. Good news, bad news. I didn't catch the last video, but the good news is, and by the way, that is bad news. You don't have to listen to me. I'm going to get a voice actor. Don't tell me who's here. Go away, people. Thank you. It's not that I don't like people. I just don't like people a whole lot. I went ahead and used this belt sander with some 40 or 60 grit belt sander. It seems to take down the material off these PVC couplings fairly well. You still have that ridge on the inside. I'm not going to worry about that. However, this is, my God, I can't see the screen. This is the long section of the Rocket, and oh my God, I'm going to go ahead and set this guy in here like that. This is the first leg of our race. I'm actually really excited because this seems to be working out well. I'm just having a lot of technical difficulties. I apologize. Kind of new to this sort of thing. Been new to it for a while. Hold on. Picking your nose ain't gonna help either. I've got to get some glue. I got to get a. There you go. I'll use this. That's fine. Hold on. You hear the disembodied voice? Very faint alarm in the background. Bunch of rich people, the Irvine Tustin area, parts, Santa Ana. Okay, maybe I shouldn't talk, I just do that. Let's set this guy to the side. This thing is a monster. Best $15 investment I've ever made in my entire life. You need a belt sander. I've already shown you why. Okay, so here we go. Here we go. Okay, so now I've punctured that. Now, why am I doing this? I'll tell you exactly why. This is my level 2 rocket effort. My level 2 rocket is going to be electronically. It's going to have, not electronically controlled. It's not going to have RCHEI ignition system, which is remote control head-end ignition system. I'm not even going to talk about that till I get that bitch patented. Is it copyrighted or patented? Who knows? But it is going to have an electronics payload bay, and this is it, the longest section. I'm just doing now what? Well, that's really annoying. This phone, I think I'm gonna have to do a factory reset. The problem is, even with that Google backing up my data, it erases this channel statistics. I have to start all over again. That creates other problems. Google is not perfect. I'm sure they try hard and they mean well, but I don't know. Okay, do I got enough glue in there? It's just kind of, there you go. You want as much coupling to show as possible. Again, you don't want the English chimney pipe. You know, London Bridge is not falling down, but all the houses are crooked. So you want to avoid that. This is not taking. I don't see much glue in there. Let me put some more glue in here. Be a little bit more liberal about it. You know, be more left wing about this. By the way, I'm not political. I don't vote. I think the whole thing is a three-ring circus. Finally, there's three portions of our government too. How does that work? Okay, so I'm more liberal with the glue. What end did I? Oh no, that was the end I put in. Okay, so I'm going to put as little of the coupling in the glue as possible. I'm going to spin it. Now, I sanded this straight across even. I didn't see any bow in the middle. This is all coming from the same piece of 1 1/4 inch diameter SCD, or hold on, SCD 26, SDR 26, which is, I think, schedule 26. So it should fit just fine. Just let it glue in place. Let it sit out in the sun and set. So this is a section that's going to go on the bottom section. Hey guys, you know what? I'm really excited about this. I want to get the nose cone on too. I'm not sure we're going to have time for that because I have an appointment to look at some a variety of used tools in Long Beach. I live in Los Angeles, and it's funny how it turns out. You know, I turned to be a fairly creative type. It almost seems like Los Angeles is a better fit. I don't know how that works, but all things being equal. Okay, so do we choose this nose cone? This guy, and this guy, and the 3 NC60 nose cones made by Estes that I ordered from Ultimate Hobbies in Tustin. Cost me $10, no shipping. Got the stuff within a week. Check out Ultimate Hobbies in Tustin on Tustin Boulevard, right catty corner from the Wells Fargo, right next to the 55 freeway. Those guys are awesome. They know their stuff. If you're into model cars, or not model cars, but RC cars, that is absolutely positively the mecca for models. Anyway, talking about this project, having looked at these nose cones, I don't want to use this. I can use this for a shorter, more decorative rocket. This guy I can use for another shorter, more decorative rocket, but something that I want more length than the overall length of the rocket on, using the nose cone. This is the design I'm settling with. This is an ogive. These all rockets nose cones are compound. This is ogive, but this is parabolic. This little tip right here, my finger's pointing at, you cut the tip off, which I don't want to do because these are wonderful nose cones. That is parabolic. Anytime you have a half circle shape on the top of anything, you can have a compound conical with a compound nose cone with double conical and a parabolic. Compound meaning there's more than one style of shape in the nose cone itself. In this case, a double conical with a parabolic is found on some of the Delta Heavies, the Delta 4s for the Delta 6s, and the Titans. However, however, on the space shuttle, the boosters, they had a straight conical. They came to a point, no parabolic. On the nose of the main oxygen tank for the space shuttle, however, was completely 100% pure ogive. It was a medium to blunt ogive, which means medium to a little bit less than medium, so kind of a short ogive shape to it. That was the center main fuel tank that carried the pressurized cryogenic temperature liquid oxygen. Cryogenic meaning down around 275 degrees Fahrenheit, below zero. Of course, those are extraordinary things. So I want this guy right here. It comes to a lesser point, so I'm going to put these two back. I'm going to use this guy. I'm going to show you what I'm going to do to get this to fit on the other section, because I want to get the overall length of my level 2 rocket on point. And the thing is about this level 2 rocket, if you go to Lowe's Hardware, you can get this material. You have to know which Lowe's Hardware to get, and I'll write the information down. I'm trying to attach a link to this channel so you can find their nearest Lowe's Hardware and get this material. These nose cones are hard to get. They're expensive. If you call up Ultimate Hobbies in Tustin, California, you order them over the phone, they have them shipped out to you for a medium price, or they can bypass themselves and just have you shipped if you get them a credit card over the phone. You need these nose cones, you need this motor tube. As far as supplies for G10, McMaster Car Online, or Paragon Plastics in middle of the Santa Ana Tustin border on McFadden next to the 55 freeway. That'll get you all the stuff you need. By the way, Paragon Plastics, I found out, can get you Garolite XX, Garolite XXX, and G10, and all grades of phenolic, stuff for pressure, stuff for heat, or both. So Paragon Plastics is the place to go. If they're not available, they can't get you what you want, for whatever reason, there's McMaster Car Online. That's MCMASTER-CARR online. They're online. They're expensive, but they're on point. So there you got your materials covered. So hold on a second. Let me get these two codes back. Headache, eating real food. I'm not sure. I'm getting a headache because I'm not. Oh no! Wait a minute. I had caffeine today. Okay, so let's take a check at this. Okay, I'm gonna sand this down again. Good, nice and firm, just as firm as it needs to be. Check the relative straightness aligned with the invisible long axis of the rocket's. This particular section of the rocket's fuselage, because you don't want yourself an English chimney pipe. And look at this. Uh-oh, a little tight. You know what? And unroll it like roll it like this. So to check for uneven seams. Of course, that can be affected by how well you square sanded each one of these individual sections. This is the middle section, electronics. This section right here that I have not finished, this is a section that's going to carry the fins and the rocket motors, the rocket's motor system. So we're going to put this aside. I'm already loving this. When I sand this section down and start putting fins on it, develop a rocket motor and rocket motor mounting system on it too, we'll be well underway. The fun part is going to be figuring out how to fit payload electronics in this section here, and how to fit the parachute and shock cords in this section here, and then again the upper parachute in this section here, which is going with this nose cone right here. And as you can see, it's a tight fit. We got a solution for that problem too. I'm really excited about this project, and I hope you are too. So let's oh boy, you know, round stuff just rolls. That's just how it is. I don't want to forget the stuff on the top. Okay, let me put this on the top of the car. I'm always leaving and coming back. What's wrong with me? Okay, so here's what we're gonna do. Sorry, I gotta get rid of the. Oh my God! You know, this is a messy business, guys. I don't know what else to say. This thing's got smudge all over it. I'll just put it down here for now. You can't see me, but you can hear me, and that's good enough. Hold on a second. God dang it, man! This stuff is unruly. I kind of see why people don't want corded tools anymore. You're a bear. Uh-oh. Yeah, I'm gonna have to retrofit. How am I doing that? I'm tired of hearing it. Somebody's car alarm is going off. It's been going off for the last probably 30 minutes. The whole time I've been here. Jeez, I need this larger tool or larger table. That's just whacked off like that. Okay, the objective here to sand this surface down as much as you can. The middle of this particular clamshell molded plastic, this is NC60 nose cone from Estes, is fairly thin. The material it's not brittle. It actually melts and is chewy. It's designed to be flexible so that, you know, Estes has been building model rockets for a long time, and I admire them for that. I'm just thinking though, I want to get the sections together instead of, well, I want to get the nose cone. You know what? Getting this nose cone on is going to involve, you know, logistics of setting up the tool to do that. So let's just, let me work with the other coupler, because you didn't actually see the process of me doing that because I had technical difficulties. So let's put this on the side here, throw that there. Wow, everywhere but where I wanted to go. I'm telling you. And I've already made a mess anyway, so let's just make more of a mess. Look at this section too. This is, let's see a shave spot there. Okay, so what do we got? Hold on. We're planning this out. Hey folks, when you're setting up the coupling system on a 3-section rocket, because the middle section is going to carry your electronics payload bay, as they call it, dual-ended deployment with a parachute, drogue and parachute, bottom end of the rocket, parachute and drogue at the top end of the rocket. That is a 3-section rocket. I'm going to have to draw a picture to explain this to you. Depending on how you want to set up the coupling system, there are 2 different ways to do it that I know of. One way is fairly complicated. The other way is a little bit simpler. But again, there's an old saying in construction and tailoring. What do we got going on here? Oh my God. Close out. Boy, this phone is really dead set working against me. It keeps, and the messages app keeps stopping, and it keeps blocking the video. I think somebody on the other end, I gotta be honest with you, I kind of think somebody's tracking my movements through this phone, and when I insult these assholes for bad programs, they hear me, so they try to make a hard time for me. So whoever you fuckers are, I want you to get off my phone and leave it alone. I said I wouldn't cuss. I'll bleep that out. It's got to stop, man. It's my phone, not yours. So mind your own business and stay off my property. Anyway, okay, so what we're going to do, here we go. We're going to sand this coupling down where its outer diameter is small enough to fit in this inner diameter. Tomorrow, when we're going to do kind of a teaching lesson, it's going to be lecture and demonstration of the 2 different ways you can set up a coupling system for a 3-section rocket. Single fuselage, 3 sections, 1, 2, 3, stacked one on top of each other, because you have a dual-ended, dual drogue and dual regular parachute type of rocket that's really going to be supported during the recovery phase, the 5th phase, the final phase of any model rocket's flight path. So, okay, so here we go. Jason, talk is cheap. All right, here we go. Oh, I got to start the car up because this tool draws a lot of amperage, and I've also got to plug it in. Okay, and I've got to plug the tool in because electric tools need electricity to run. Don't ask me to explain why. There we go. Charisma, baby. Charisma. Here we go. We're going to use, let's get this up just a little. We're going to use this belt sander to remove outer material from the outer diameter of this coupler, make it fit the inner diameter of the 2. I already showed you that. Let's do it now. So now it seems like the inverter is more well programmed and suited for the power draw of this. So that's a good thing. problem is, you know, the funny thing about plastic heats up kind of like fiberglass and tin and copper, like any other material. You gotta watch your fingers and wear the work with gloves. I can't wear gloves, my hands are too big. boy, this is making a mess. Anything else to look at? Wow, I kind of really. Yeah, there's something. All right. Sorry, folks. taking a musical break here for a sec. Man, I shot a video last night, but it was at night, and I was just running off saying and doing stupid things, and I made the mistake of uploading that video. I swear I don't drink. I don't drink or do drugs or anything. It's just when the sun goes down, I just get really tired, and I kept falling asleep. When I talk technical, I can put myself to sleep. So anyway, let's check the fit of this coupling. Okay, so, but the thing is, it fits on the other end. Okay, so it's a little flared on this particular side, so we're going to keep sanding it down. Let me get a drink to wet my whistle. Look, check the fit. Okay, both ends. You know what I'm thinking? There we go. I'll put that end in. That's a tight end. Alright, so we are done. Let me get this thing off the table while we're at it. Gee, man, like a snow globe in here. Get everything off. What a mess. I have to wash this car when I'm done. You know what? I need to wash it anyway. Here. You know the thing about round stuff? It tends to want to roll. Oh my god. There you go. Boy. Christmas in July. Look at all that stuff. That's one thing about machining PVC. Machining any type of plastic or metal. You're going to get shavings. That stuff is just annoying. Okay, so we're going to try this particular angle and perspective because I want to clean off that side of the table. I tell you what, everything is basically obscuring the line of sight for this camera, and it's not there. Like that, like okay, like that. I'm going to clean it like that, like that, like that. See how much time production takes? Half of this video is me taking care of production. To get the money, I'm definitely going to hire a camera person. I'll pay them $50 an hour if I get the money to do that. Some hungry college student or something, college student or somebody who's into this sort of thing, wants to start their own blog, learn the ropes, but I have the money first. Oh, goodness gracious. Stuff everywhere. Actually, I want to run the car through the wash. A couple places I can do that. Alright, okay, so now I want you guys. Okay, here you go. I want you guys to see this and how this works. These slip fittings, the molds they use, the factories that manufacture these slip fittings for PVC pipe, for plumbing, and irrigation, their molds aren't perfect. They don't machine the molds to exacting specifications in certain places, and the reason is it's just not that important. The application for this particular part has nothing to do with rocket couplers, and I cannot imagine the longest stretch, the most wildest imagination anybody have any idea that dear old Jason Watts will be doing that with their product instead of using it with PVC pipe to establish irrigation or plumbing. Some unfortunate soul that wants this stuff. But here's the thing. These couplers, the one side is ramped over the other. I did a straight grind on both ends. I tried to put a little bit more force in the tight end, and it ended up giving this coupler a little bit of a rocker in the middle, sort of a convex instead of a concave. So I'm thinking to myself, the solution to that problem, being that I already know which end of which section I want to put this in, I'm going to put the end in that is the tightest. And since it's the tightest, that means I can install it the least amount of way in, and I can have the most amount of coupling sticking out to put as much grab, loose loose grab, but grab and centering grab on the section that it does go into. And I'll show you that in a section. I'll show that. I'll show you that in a second. Here, I'm gonna put everything back on the table. So we're gonna glue this thing in place. But you know, again, remember which side is the loosest. This is the loose side. There's no point. You put this in there, yeah, it makes the assembly a lot easier, but this is the tight side. I can actually see a little bit of roundness, and it's flaring towards the end because the cast, the mold they use to make these parts at the factory is slightly ramped on one side. I don't get it, but that's just the way they do it. That's the way everybody makes these couplers, doesn't. They think it's some type of design standard. Well, it's a slip fit coupler. It goes on both ends. There's no need to reinforce one side over the other because the part is asymmetrical and it joins two cut pipes. There's no more force or structural strength on one side than there is the other. Both sides of the coupler have to do the same job. So it just, to me, it's just laziness or poor workmanship. So this is the loose side. This is the tight side. You want this in, like I said, because it's so tight, you can put less distance in and just glue it and hold it in place. You can have this whole distance, mind you that it's aligned with the invisible imaginary long axis, dead parallel the interior of this particular section of the rocket's fuselage. That way you don't have the London bridges not falling down chimney stovepipe sort of, you know, bend to it, because you know crooked rockets fire real funny and they're entertaining, but you want a professional touch, you want a professional effect. So that is the tight end, and confirming that, leave that there. It's going to want to roll. This stuff has a mind of its own, and we're going to apply a liberal amount of cyanoacrylate here. The CA does just fine with PVC. You know, in all honesty, when you're working with craft paper, you can use super glue. When you're working with phenolic, you can still use super glue. PVC and ABS, for whatever limited applications you're working with, ABS has limited applications on anything that has to do with anything with rockets, but you know, you can't use it. Here, I told you the thing wanted to slip. But you know, this goodness truth, a lot of people tout the merits of epoxy, and I've talked about this before. Epoxy is very, very, very difficult and cumbersome and expensive and messy to prep, but it's easy to apply. It's a general all-purpose, but epoxy is overkill for PVC. You don't need it. Polycarbonate, note that's the loose side, I can't do that. Polycarbonate and oh my goodness, I'm gonna have to sound that down. I'll have the block sound it down. Oops, I'll clean up my skin on my hand. Polycarbonate, PVC, ABS, your ticket. Your ticket is always going to be cyanoacrylate. Cyanoacrylate being the more common nomenclature for cyanoacrylate is super glue. That's just Piedmont. That's a kind of a Piedmontese saying. Piedmontese is Italian for slang. So you know, I had to explain that twice. I'm the dumbest smart person you'll ever meet. But this is the loose end. We have some time, but I'm going to turn the engine off in my car. I want to fit the nose cone in this bad boy, and I'm looking at our time. We're at 33 minutes. We might be able to pull that off, but the material on that nose cone's hip, the stepped hip, is so thin. I'm thinking ultimately I can only take the casting seam off of it with a barrel sander. I'm thinking I'm going to have to work on the interior diameter to get it to fit. But here's the thing. This is the nose cone section, and I can't seal this up by gluing on the nose cone to this end. And why is that? Because, as of course, this is the end. I need to go ahead and install from the top the anchor spool, and since it's a level 2 rocket, I might have to consider some type of way to make this rocket modular, or not modular but serviceable, where I can take out the bottom and top anchor spools. And of course I do have to be able to remove the electronics bay. There's no way I'm going to install, seal, and glue in place an electronics bay, even with through holes, and you can see the lights or the fuselage. I don't do that. You want your payload to be removable, but then again, me saying this is like every car needs a steering wheel, so I hope you know that. So maybe I'm just kind of a jerk for saying that, assuming you're really dumb, and I apologize for offending you in any way, shape, or form. But we've got a few minutes. I just want to sit down and get something to eat and collect myself somewhere where I can go and relax without being hassled. And I think I want to do that between now and the time I have to be in Long Beach to look at that used tool equipment dealers' tools. So I'm thinking we might want to consider working on the inner diameter of this end of the rocket here. We can do what's called a temporary slip fit. I want to get the nose cone installed. I want the full length of the rocket. I want you guys to see that at the end of this video. I want this to come alive. The next thing is we're going to set the fins, and then after, not before, after we set the fins, we're going to do the launch slug. And anybody know why? I'm going to tell you exactly why. Because if you set the launch slug that goes on the outer surface of the rocket itself, if you set the launch slug in place, you're going to have a really difficult time setting the fins in such a way that they don't interfere on the exterior vertical surface of the rocket with the launch slug's hole. The launch slug is going to have a fairly small hole, so which means when it fits on the rail's not going to be able to bend sideways, which means if you set a fin, oh shoot, this again, huh? Stop, you guys. If you set a fin right here and you set the launch slug right there, because you put the launch slug on first, and the fin, you use the grinding tool to set the rut for the fin, set the fin up there. The only thing you can do is break the launch slug loose, and if it's plastic, you have to grind it, resand it, refinish it, and that's a disaster. One cannot interfere with the other, and of course, placement of the fins is absolutely positively critical. And let's talk about that real quick. Let's do a quick review. There's several calculations for any rocket to be successful. The first is center of pressure, center of gravity, and then the second is center of gravity. Third consideration is almost as important as power to weight ratio, because you want a flight that goes more than 500 feet in the air. I mean, it'd make a great looking firework on New Year's Day or Christmas or for July the 4th, but you want your rocket to get some real serious altitude. So we have center pressure, center of gravity, power to weight ratio, which is measured in the rocket's motor by what? That's burn time times total overall thrust, which is total specific impulse. Again, total specific impulse equaling what you multiply, total rocket motor's pressure output times the burn time. So pressure times burn time equals total overall specific impulse, or specific impulse of the rocket motor. You got that calculation, use that as a ratio to how much the rocket weighs, with the loaded motor, with the electronics and battery, with the parachutes and drogues, with the shock cord sections, the couplers, the paint, the graphics, everything, the counterweight, the nose cone, anything else you want to put in the rocket, including a downward facing camera, upward facing camera. If it's an egg loft rocket, or you want to put some type of insects in it, you need to do research on the life of an insect that goes in the upper atmosphere. Again, you have to consider the overall weight, a specific impulse, just burn time times total thrust of the rocket motor, and then from there you have that power to weight ratio equation you can play around with, but that has to be correct. You need high altitude flights. The rocket needs to be able to fly steady throughout all phases of its rocket flight, from power descent to coast to apogee to descent to recovered descent. Okay, so we got those three. What is the fourth one? That is a good question. We talked about the fourth one. It kind of has to do with drag, coefficient of drag. But since a rocket's launched vertically, there's not a whole lot of vertical surface area there's not a whole lot of horizontal surface area that's facing the blunt end of the upward vertical movement of the rocket itself. The fourth consideration is the total square area of the control surfaces, which are considered the fins. The number of fins times the size. This is where you have to know a little bit about geometry, calculating surface area of each fin, multiplying it by the number of fins, coming up with that ratio of surface area to length and diameter of the rocket. The length times the diameter, and the fins, the surface area of each fin times the number of fins. So you have two multiplications on either side of the equation. Then the equation, you have the fin's surface area to the size and diameter of the rocket ratio. You have that as a single ratio. That ratio, power to weight ratio, you have your center of pressure, which is rocket's dynamic balance throughout the 5 phases, well, mostly through the powered flight and coast and apogee, is when center of pressure is critical because that determines the rocket's vertical angle of attack and or balance throughout dynamic powered flight. A powered dynamic flight, which is powered flight, first phase, or coasting, even second phase. But mostly that first phase of a rocket's flight path which is powered flight. The rocket has to fly straight and steady. Center of gravity is one thing. Center of pressure, get that calculation correct, and you balance out the rocket for a correct center of pressure, the rocket's going to fly in that first phase of the 5 phases of the rocket's flight path. Okay, center of gravity is the static balance of the rocket itself. Leading edge to the bottom first third of the rocket is a rule of thumb for me. We don't regard coefficient of drag. My next is my favorite power to weight ratio. Guys, if you want to go chasing after your rocket for 6 weeks or for 6 miles, you know, put a G80 rocket in one of these teeny little eliminator Estes eliminator rockets, or even one of the tall ones. They're overpowered. They're grossly overpowered rockets, and you're going to walk for miles to recover that thing because they're hot rod rockets. But the problem is the motor's so powerful, those rockets rip off the pad literally like a bullet out of the barrel of a gun, and you can see them as they're descending, and they're literally half a mile away from you, just thousands of yards away. Not enough power. You're going to have a decorative launch, very slow off the pad, which is going to affect your center of pressure and gravity. So you're going to have to definitely have those calculations correct. If your rocket is underpowered, be careful. So you want your rocket to kind of zip off the pad to correct any type of mistakes you made with the center of pressure or center of gravity calculations. So to watch your power to weight ratio, and we'll talk about that more. We don't really have the time to explain that in detail. There's a rule of proportions and there's intuition. You got to start thinking and building stuff in your head well in advance before you commit putting rubber to the pavement and start physically building your rocket. Level 1 certification, level 2 certification, God forbid, the final frontier, level 3 certification, or in most younger people's case, you just want to build something that will fly and help you have a lot of fun at the next NAR Tripoli rocket launch. So, and again, so we got center of pressure, center of gravity, power to weight ratio, total fin squint area times the size and diameter of the rocket, which would give you fin area to rocket size, overall rocket size ratio. That has to be correct as well. You can't have fins on there that are too large. You can't have fins on there that are too small. They don't provide any guidance. You want a straight, level, dynamic flight. You want to look as good as possible at that rocket launch because, you know, there might be some women there, some young ladies that you want to impress. There might be some boys you want to impress if you want to be a smart girl. I'm just saying, and you know, I shouldn't mention anything like that, but I'm going to anyway. My car is still running. You know what? I'm wasting gas. I'm wasting your time. We're done. So let me go look at the clock and see how much time we have left. We're at the 43-minute mark. I might be able to fit the nose cone loosely, but then again, I'm worried that we may not. Let me check things out. I'll be right back. Hey folks, we've had a great time. I've just noticed, you know, in summer it's kind of hard to tell what time it is, especially in California because it's so bright and beautiful out. Before we close up shop and end today's lesson, I did want to show you the overall length of what my level 2 certification rocket is going to be, plus the nose cone, wherever the heck it is. I put that thing. Oh, there it is right there. Look, see? Bouncing the wrong box. It has the extension cord coming from the inverter in front. That was fun. It was not easy. Nothing worth anything in life is easy, folks. I guarantee God dang it. That's me. All right, so here we go. I'm hooking the 3 sections together. Look at that. That's beautiful. You know, the base is a little bit tight. Okay, I don't feel much wobble. Okay, so listen, guys. All right, I'm going to put this right here, and I'm hoping you can see it. And I'll just kind of set the nose cone here. Of course, we got a ways to go with this rocket. Look at anything that's round and wants to roll. Here you go. Can you see that? Look at the length. Okay, and there's my hand for perspective. Okay, that is a wonderful airframe. I'm very happy. All three sections, 1, 2, 3, have been cut from the same section of 1 1/4 schedule 26. Thin walled PVC pipe that I got at Lowe's. Love the place. So they are copyright infringement. Free advertising. They're going to kill me. Uphill battle. I'm frustrated. Okay, so here we go. You didn't see or hear that. So that's it. My name is Jason Wampler. We're going to call it quits at this time of 45 minutes and 29 seconds. We'll see you tomorrow. Tomorrow I want to draw some pictures, kind of show you how to figure things out, different coupling systems. Hold me to that promise. Hit the like, hit the subscribe, and for goodness sake, somebody start speaking up. Leave some comments. There's no such thing as a bad answer. There's no such thing as a dumb question or comment, but there's no such thing. There's nothing like regret over inaction, not doing anything about something. All right, we'll see you guys tomorrow.